kids, welcome back to math. Hope you're having a great day. Today we're going to talk about how you can graph an equation without even making a table of values. And let's take a look at the first one I want to do here. So I have a word problem, or a scenario I should say. So a baby elephant grows at a rate of 100 pounds per week. Right now, it weighs 50 pounds. So it starts with, time now, it starts with 50. And let's see, if it's growing, it's going to be addition. And what's its rate of change? Here it is right here, 100 per week. And so our equation will be, let's use P for pounds and W for weeks. So the total poundage of that elephant will be equal to the start number of 50 plus 100 times the number of weeks. Now, I'm going to graph in pen because I haven't been pleased with the way my pencil's been showing up, but I really want you to use pencil because if you make a mistake, you want to be able to erase. And if I make a mistake, I'm going to have to make this paper all over again. So I'm really hoping not to make a mistake. Okay, my start number is 50, right? There it is right there. Time now, this is the start number. Remember, this always appears on the y-axis. This is my y-intercept. So I can go to 0, 50. There's the starting point. Now, if it's 100 per week, I want to show that at week 1, if it's gained 100 pounds, it will go from 50 to 150. So at week 1, it will be 150. So what I really did was I went over to 1 week and I went up 100 pounds from there. I can really do that again. I can go over to 1 week and then go up to 100 pounds from there. That's it. That's the graph of the equation. Let's look again. So it started at 50. After 1 week, it gains 100 pounds. So I go from 50 to 150. So I went over 1 week and up 100. Over 1 week to 2 weeks and up 100 pounds. I'm going to go over to 1 week and up 100 pounds. And that is making a graph without a table of values. Now, you can't do this with every graph on the planet, but when it's a linear equation of the form that we've been using, like this works every time. So cool. And now we're ready to take a look at this one right here. So let's see. I'm looking for my start number and my rate of change. This is my start number. This is my y-intercept. So what that means is I'm going to find 3 on the y-axis, and that is where my graph will cross the y-axis. We've thought of this as our starting point. Now, the rate of change means that for every time x grows by 1, y will grow by 2. So if I go from this point over 1 unit to 1, a rate of change of 2 is actually a slope of 2, so I'm going up 2 units. So again, this rate of change of 2, the slope of 2, means that I'm going over 1 value for x and up 2 values for y. Over 1, up 2, and so on. Now, this one, unless you have a word problem that makes negative numbers meaningless, your graph is actually going to extend forever in both directions. It's only when, let's say this were time, There's no such thing as negative time or negative orders of wings. But if you're just graphing a plain old equation with no scenario, it will have arrows on both ends. Okay, so there's that one. And we're going to do 2 more. No, we're going to do 4 more. Let's see. Did I mix this up? Let's see how we're doing time-wise at the end of these. Okay, I've got y equals 3x plus 3. So this right here is my y-intercept. So I'm going to 0, 1, 2, 3. Let me number these because I know at this point that's easier for you guys. 1, 2, 3, 4, 5, and so on. So my rate of change of 3 means I go over 1 and up 3. 1, 2, 3. Rate of change of 3 means I go over 1 and up 3. 1, 2, 3. That's it. That's so much better than making tables of values. So I know you're wondering, why did I make you make tables of values if all you really need to do is this? Because doing it this way is meaningless unless you understand what these points actually mean and what the equation actually means. So we've been building the understanding of the concept through the work that we've been doing, and now I'm actually teaching you the final method that you need. All right, here we go with another one. Let me fill these in. 1, 2, 3, 4, 5. And let's see, 4x minus 1. If I box in my subtraction, can you see that my start number is -1? My y-intercept is -1. So instead of finding my y-intercept up here, it's actually down here at 0, -1. And let's see, I have a rate of change of 4. So that means go over 1 and up 4. 1, 2, 3, 4. Rate of change is 4. I go over 1 unit and up 4. 1, 2, 3, 4. Done. Once you get the hang of these, they go so fast. You're going to be pros at this. This is what you'll be starting with in the fall in the 9th grade. And you're going to be in great shape because you already know how to do this. Okay, let's do these last 2 just so that you can really get the hang of it. Okay, I already did the numbering on this one. So 16 minus 3x, that is a negative rate of change. My graph is going to be heading in this direction. A negative rate of change means a negative slope. And rate of change is slope. They're the exact same thing. All right, here's my y-intercept right here, 16. So I know that on the y-axis, I'm going to 16. And now this one is a little trickier because with a -3, I go over 1 and I want to go down 3. But look, I'm counting by 2's here. Think about that for a second. So if I want to show a negative rate of change of 3, I'm going to go over 1. Now I've gone down 2, right, from 16 to 14. My next point is actually right there. So again, a rate of change of -3. I'm going over 1. There's down 1, 1, 2, right there. And so on. So if I had enough room on here, I would have been much better off counting by 1s so that I wasn't trying to graph between the grid lines. And again, unless you have a reason why negative numbers should not be included, you're going to put arrowheads on the end. All right, last sample. So y equals -4 plus 2x. 1, 2, 3, 4, 5, and so on. 1, 2, 3, 4, 5, and so on. What's my starting point? What's my y-intercept? It's -4. So I'm going down to -4. 1, 2, 3, 4. I have a y-intercept of -4. And that rate of change of 2, that slope of 2, means I go over 1 unit and up 2. I go over 1 unit and up 2. Over 1, up 2, etc. Now, if you're thinking, this is nuts, I don't get this, you're in great company. Because a lot of kids are feeling the same way. What you want to remember is that you're looking for your start number, that you're either adding or subtracting, and then you're doing the something per something. So here my start number was -4. I'm adding 2 per, this is actually 2 per increase of x. So if it helps you to make this and then do the graph as a stepping stone skill, absolutely feel free to do so. So I'm going to give you 4 equations to do on your own. Remember, you're doing these on actual graph paper, or you could do them on an online graph paper and print those and send me copies of that, or share a document. That would be fine too. So without creating a table of values, you're going to graph each equation. And remember, each time you're looking for your start number and your rate of change. The start number will be your y-intercept, and the rate of change is actually the slope of the line. Best of luck. I know this is challenging to learn without me there. I think your best is going to be just fine, and we'll continue working on this skill. All right, kids, good luck with this.